If we are asked about vectors in space, vectors in space, notice I'm given a point P with curvy brackets. The curvy brackets mean this is a point. And point Q with curvy brackets. The curvy brackets mean this is a point. If you're asked to find vector PQ, well, that's a very specific vector from point P to point Q. Recall that vectors are essentially directions that tell you how to get from your initial point to your terminal point. So this vector PQ will be x final 2 minus x initial, comma, y final, which is 5, minus y initial, which is 2, comma, z final, which is 11, minus z initial, which is 7. Now that that's a vector, I'm going to put my crimped brackets there to say 2 minus a negative 3 will be 5. 5 minus 2 is 3, and 11 minus 7 is 4. There is my vector from P to Q. So, here's a slightly different problem with the same concept. This time I'm given initial point P. How do I know it's a point? It has the curvy brackets. And vector V. How do I know it's a vector? It has the crimped brackets. And if we are asked to find terminal point Q, we're starting here at P, 4, negative 3, 11, and we're going to point Q, which is somewhere. I don't know it's X or it's Y or it's Z, but I do know that the directions are negative 7, negative 2, 20. And what's the easiest way to find Q? Well, it's simply where you're starting plus the direction will tell you what the final destination is. So 4 plus a negative 7 is negative 3. Negative 3 plus a negative 2 is negative 5. And 11 plus 20 is 31. Kind of like if you're here at school and these are your directions home, what are the coordinates of your home?